Today's notes are going to be on 4.2, solving systems of equations using substitution. Um, Not all systems can be solved by graphing. Therefore, you may need to solve a system algebraically. So right here, look at how we graph these two. Let's say this was equation 1 and this one was equation 2. As you can see, the point of intersection is not an exact coordinate. So from the graph, I cannot tell what the intersection is. So the point of intersection may be a decimal. On this graph right here, let's say this was equation 1 and this is equation 2. Notice that the point of intersection, they are going to intersect at some point above here. So the point of intersection may be off the graph. So these two examples are great examples of why we will turn to other methods of solving a system besides graphing. Substitution. So substitution obviously has the word substitute in it. So we are going to be substituting one equation into the other. Now, if I said y equals 10, everywhere you see a y, you would plug in the number 10. But in this case, if we look at the first equation, this is equation 1, this is equation 2. If you look at the first equation, it says y equals 3x minus, just 3x, sorry, 3x. So since it says y equals 3x, what you could do is you can go to the second equation, and where you see the y at, you can plug that in. So this y is going to get plugged into here. So what I'm going to do is the first step is going to be to substitute. First step will be to substitute. You always plug one into the other. So watch, I'm going to write the second equation down, which says 4x plus 3y equals 26. Now I'm going to go back, and where I see the y at, I'm going to erase it, and I'm going to plug this 3x into there. And that's what I'm going to be solving. And now if you notice, I only have the variable x. I don't have two variables. So here I'm left with 4x plus 3 times 3x is 9x. These are like terms and they're on the same side, so I can go ahead and add them up. That's 13x equals 26. Since I'm solving for x, I'm going to go ahead and divide both sides by 13. So if I divide both sides by 13, x equals the number 2. Now, just like before, our answer has to be an x and a y. So the next step, I only know what the x is. My next step is to plug in. Now, it doesn't matter which one you plug it into. I can plug it into the equation 1 or equation 2. One of them will be easier than the other, but you'll still get the same answer. I'm going to go ahead and plug into equation 1, which says y equals 3x. Here it says x equals 2, so where I see the x at, I'm going to erase it, and I'm going to plug in the number 2. And 3 times 2 is 6. So your solution is going to be an x and a y. So the x goes first, the y goes second. That is our solution. In order to solve by substitution, you need to make sure that one of the variables is isolated. You see how I said y equals? All right, let's go on to example 1b. Here is equation 1, here is equation 2. All right, well, equation 1, if you look, it says y equals. So perfect. I'm going to plug all this good stuff, the 6x plus 7, into the y of the second equation. So first step is going to be to substitute. So I'm going to go ahead and I'm going to write the second equation, which says 3x minus 8y equals 4. Now I'm going to go ahead and plug equation 1 into equation 2. So I'm going to erase y, and I'm going to replace it with the good stuff, the 6x plus 7. 6x plus 7. Now I'm going to go ahead and I'm going to simplify. So here I'm left with a 3x. Right here, you are distributing a negative 8. Negative 8 times 6x is going to be a negative 48x. And then right here, don't forget, that's a negative 8 times a positive 7. That gives you negative 56. On the left side, we have like terms. Right here, 3x minus 48x is negative 45x. Going back to two-step equation, we were solving for x. Do not move the 45 because it's glued to it. You want to move the minus 56. So the opposite of minus 56 is to add 56 to both sides. So if I add 56 to both sides, 56 plus 4 is going to be a 60. And then the last step is to divide by negative 45 to both sides. So let's see what that equals. 60 divided by negative 45. That gives me a fraction. A decimal. Let me go ahead and make it a fraction instead. Negative 60 ABC 45. I get that's negative 1 1/3. If I change that back into an improper fraction, that is negative 4/3. I like that better. Now, if you would have wrote negative 1.333, that's still technically correct. I'm not done. I only have one variable. I need to find the next one. So we need to go ahead and we need to plug in. Now you could pick whichever one you want. One of them is going to be easier than the other. I'm going to go and plug in the top. The top says y equals 6x plus 7. I'm going to plug in the x. So the x is going to be a negative 4/3. So the x is going to be a negative 4/3. Let me type that in my calculator. So I have a 6 parenthesis, negative 4/3. So negative 4 ABC3 plus 7. And my answer is negative 1. So my solution here is the x goes first, which is the negative 4/3. The y goes second, which is a negative 1. Now I want you guys to hit pause and I want you to try the next two on your own. I'm going to go ahead and continue. So when you are done, you guys can check your answers to make sure you guys got it correctly. So here is equation 1. Here is equation 2. On this one, the variable that is isolated is the x because it says x equals. So x equals y plus 6. So that is what's going to get plugged into this second equation. So the first step will be to substitute. So I'm going to substitute into the second. Now, it's not always the first goes into the second. Sometimes the second can go into the first. It is whichever variable is isolated. So here it says x plus y equals 10. Well, from the first equation, we know what x equals. So I'm going to erase the x, and I'm going to replace that with the good stuff, the y plus 6. Combine like terms, y plus y is 2y. I'm going to go ahead and subtract 6 to both sides, so 2y equals 4. And then divide by 2 to both sides, so y equals 2. After I substitute, I need to plug in. I'm going to go ahead and plug into the top one, the one where the x is already isolated. And make sure you are plugging in the 2 into the y. So right here, 2 plus 6 is going to be the number 8. Now, when you're writing your point, it doesn't matter that you solve for the y first. The x always goes first. So the x is the number 8, the y is the number 2. The order matters. X is always first, y is always second. On the next one, this is equation 1, this is equation 2. On this one, the y is being isolated, so the y is going to get plugged into the y. So first step is to substitute. So I'm going to go in, I'm going to write the second equation, which says 2x plus 3y equals negative 7. Now I'm going to erase the y because that's the one that's isolated. And I'm going to replace the y with a 2x minus 1. 2x minus 1. So here I'm left with a 2x. I'm distributing a positive 3. Positive 3 times 2x is positive 6x. Positive 3 times negative 1 is negative 3. I'm going to combine like terms. That is going to be an 8x minus 3. I'm solving for x, so I'm going to go and add 3 to both sides. So negative 7 plus 3 is going to be negative 4. And when you divide by 8 here, negative 4 over 8 is actually a negative 1/2. Look, negative 4 ABC 8, that equals negative 1/2. Next step will be to plug in. I'm going to go ahead and I'm going to plug it into the one where the y is already isolated. Y equals 2x minus 1. Make sure you're plugging in the negative 1/2 where the x is at. Right here, your 2's are going to cancel, and you're just going to be left with negative 1 minus 1, which is negative 2. So the final answer here is x is negative 1/2, y is negative 2. Right here, it says compare graphing and substitution method. A vacation resort offers surfing lessons and parasailing. If a person takes a surfing lesson and goes parasailing, they will pay a total of $175. On Friday, 16 people go parasailing and 20 people go take surfing lessons. The resort collects a total of $3,101 for the activities. How much does each activity cost? So right here, we are going, oh, sorry, I wasn't even paying attention. It says create two equations from the given information. And it is important if you are trying to solve the two different variables, you will need two different equations. Okay, so I need to go ahead and I need to let's say we're going to let X equal the cost of a surfing lesson because we have surfing lessons and we have parasailing. So I'm going to go and let X equal the cost of a surfing lesson. And I'm going to let Y equal the cost of a parasailing. Now, the first equation, it says, if a person takes a surfing lesson and goes parasailing, they will pay $175. That's one equation right there. One surfing lesson, one parasailing equals 175. So I'm going to set X plus Y equal to 175. That's one equation. The next equation says 16 people go parasailing. So that's going to be a 16Y. And 20 people go surfing. So surfing is going to be X. So then that's 20X. And that total cost $3,101. So I'm going to go ahead, and if we were to graph this, that would be your answer right there. That would be the answer here. So remember that X is going to be the surfing lesson. So the surfing, that's X, that's Y. So basically just from here, from the graph, the surfing costs $75.25, and the parasailing cost $99.75. I'm going to go ahead and solve this by substitution. So this is equation 1. Equation 1 says X plus Y equals 175. Equation 2 says 16Y plus 20X equals 3,101. So here's equation 1, here's equation 2. The X is not solved for, or the Y. It does not say X equals or Y equals. So what we need to do is we need to rearrange one of them to solve for X or solve for Y. So that's what we are going to be substituting into the second equation. So I'm going to go ahead and I'm going to take the top equation. If I just take equation 1, that says X plus Y equals 175. I'm going to go ahead and just solve for X. So if I subtract Y to both sides, X is equal to 175 minus Y. So I can rewrite equation 1 as X equals 175 minus Y. Those are the same exact equations. So this is what's going to get plugged into the bottom equation. That's going to be my substitution right there. You need to solve for either x or y. So the first step will be to substitute. So I'm going to substitute into the second equation. The second equation says 16y plus 20x equals 3101. I'm going to erase the x because that's what I'm substituting. And I'm plugging in the 175 minus y. 175 minus y. I'm going to go ahead and I'm going to distribute the 20. So that's 16y plus 20 times 175 is equal to 3,500. And then 20 times y is going to be 20y. I'm going to combine like terms. 16 minus 20 is going to be a negative 4y. I'm going to subtract the 3,500 to both sides. So I have a negative 4y equals, that's negative 399. And the last step is to divide by negative 4. So negative 399 divided by negative 4, that equals 99.75. And we knew that, look, the cost of parasailing was $99.75. Next step is to plug in. Now, when you plug in, it doesn't matter. You can plug it into this one or this one because they're the same thing. I'm just going to plug it into this one because the x is already isolated. And the y equals a 99.75. So I'm going to put that in. 99.75. So 175 minus 99.75. And that equals 75.25. So X represents the surfing, and surfing costs $75.25. So do both methods work? Yes, they do. Yes, they do. But imagine from the graph, I couldn't tell that that was 0.25 and 0.75. When would you choose to use the graphing to solve a system of linear equations? And when would you choose to use substitution? I would choose graphing when you have a y equals, when both of the equations are y equals. These were not y equals. So we had to solve for y in order to graph it. And then the point it couldn't have been at a decimal. So I would use graphing when both equations are in y equals mx plus b form. And the point of intersection is not a decimal. I would use substitution when one of the equations has one of the variables isolated. I would use substitution if I had an equation that already had an isolated variable. And although this one, the variable wasn't isolated because it said x plus y equals 175, it was very easy to make it isolated. System of with infinity many solutions or no solutions. Now remember, infinite many is when it's a true statement. No solution is when it's a false statement. So let's see here. Here's equation 1. Here's equation 2. The first step is to plug one into the other. Now look at right here. It says y equals 3x plus 1. That is what's going to get plugged into the second equation. So the first step is substitution. I'm going to write equation 2 which is 6x minus 2y equals negative 2. I'm going to plug in the y, so I'm going to erase the y and plug in a 3x plus 1. So now that is 6x. I'm distributing a negative 2. Negative 2 times 3x is negative 6x. Negative 2 times 1 is going to be a negative 2. Now, when I combine like terms, 6x minus 6x, those actually eliminate. And I'm left with negative 2 equals negative 2. I have no variables here. So all my variables canceled. And that is a true statement. This is a true statement. So because it's a true statement, this is going to be infinite many solutions. Now, what does that mean? That means that these are coinciding lines. They mean that they're the same exact lines. Coinciding lines. They are the same exact line. On the next one, here's equation 1, here's equation 2. Now the top, it says 5x minus y, so one of the variables is not isolated, but on the bottom it says y equals. So now you are plugging in the bottom equation into the top. So first step will be to substitute. So now you're substituting the bottom into the top. So I'm going to go ahead and write the top equation. The top equation says 5x minus y equals negative 7. I'm going to erase the y. And I'm going to plug the bottom equation in, which says 5x minus 4. Now, you see that negative? That says minus the entire equation for y. So this negative has to be applied to both terms that the y equals. So this is going to be 5x, negative times 5x is negative 5x. Negative times negative 4 is going to be positive 4. When I combine like terms, these two eliminate. 5x minus 5x cancels. And I'm just up with 4 equals negative 7. Well, does 4, look at no variables, and does 4 equal negative 7? No, it doesn't. That is a false statement. So because that is a false statement, this is no solution. That means that there's no point where these two graphs will cross. So why is that? That is because the two lines are parallel lines. They have the same slope. So they'll never cross each other. Go ahead and hit pause. And I want you guys to try 3A and 3B. And then hit play and see if you guys get the answers correct. I'm going to continue on. First step will be to substitute. Now the bottom equation has the y by itself. So the bottom equation is now going to get plugged into the top. So the top says x plus y equals negative 4. I'm going to erase the y and plug in a negative x plus 5. Because that is a plus sign, those parentheses don't actually play a role here because technically you're just distributing a positive 1. So the parentheses aren't going to play a role here. X plus negative x is going to cancel out, and I'm left with 5 equals negative 4. Now that is a false statement because 5 does not equal negative 4. And false statement means no solution. On this one right here, this is equation 1, this is equation 2. I'm going to go ahead and it says y equals, so that's going to get plugged into the bottom equation. So on my substitution step, I'm going to write the bottom equation down, which says 2x plus y equals 5. I'm going to erase the y and plug in a negative 2x plus 5. Once again, that parentheses are not going to play a role here because that says plus. So now when I combine like terms, negative 2x plus, positive 2x plus negative 2x, those eliminate. And I'm left with 5 equals 5. 5 does equal 5. That is a true statement. So since that's a true statement, this is infinite many solutions. Model using system of equations. Nate starts a lawn mowing business. In his business, he has expenses and revenues. Nate's expenses are the cost of the $200 lawnmower. So this is how much he's spending. And the gasoline costs $2 per lawn. His revenue is $25 per lawn. So that's his profit. At what point will Nate's revenue exceed his expenses? So basically, when is he going to start making money? So we need to go ahead and we need to we're going to let X equal the number of lawns that he cuts. And then I'm going to let Y equal the total money, expenses, or revenues. So Nate's expenses. So remember, he spends $200 on the lawnmower plus $2 per lawn. So his expenses, this is going to be Y equals, he spends $200 plus $2 per lawn. Remember, the word per means multiply, and lawns is going to be X, so that's going to be a 2X. Now his revenue, he makes $25 per lawn. So the cost here, he's going to make $25 per means multiply, lawns is X. So there's our two equations. Our two equations are going to be Y equals 200 plus 2X and Y equals 25X. Now on this one, if you notice, both Y's are isolated. It says Y equals and Y equals. So I'm going to go ahead and I'm going to substitute. And when I substitute, I'm going to substitute the bottom Y into the top Y, which means I just set these two equal to each other. So this is going to be a 25X equals 200 plus 2X. I just set them equal to one another because that says Y equals and that says Y equals. I'm going to go ahead and subtract 2X to both sides. So I have 22X equals 200. And then when I divide by 22, let's see, 200 divided by 22, that equals, oh wait, not 22, 23, sorry, 25 minus 2 is 23. 200 divided by 23, that equals 8.695, which that 5 is going to make that round up. And to make that round up, it's going to go to 70. So basically, it's not going to be $8.69, or it's not going to be 8.69. It's going to be 8.7. So right here, X is going to be 8.7. Now remember, X is the number of lawns. So you can't do 0.7 of a lawn. So you have to make that round up. So right here, Nate's revenue will exceed his expenses on the 9th lawn. That's what that stands for. All right, let's check for our understanding now. Now, do you understand? It says, how do you substitute to solve a system of linear equations? You need to isolate one of the variables. We need to isolate one variable and substitute its value into the second equation. Do not plug it into the same equation. You have to plug it into the second equation. Then we need to solve for the first variable. When we are done, we need to substitute the value of the first variable into the second variable to solve for the second one. When is using a graph to solve a system of equations more useful than the substitution method? Once again, when you have y equals mx plus b for both and the point of intersection is not a decimal. When both equations are in y equals mx plus b form and the point of intersection is not a decimal. Simon solves a system of equations in x and y by substitution and gets an answer of 5 equals 5. Okay, so that means all the variables cancel. He states that the solution to the system is all values of x and y. Describe Simon's error. So although 5 does equal 5, the solutions right here just basically mean that they're coinciding lines. So there is solutions, it's just all of the solutions. So although the answer is infinite many solutions, the solutions only exist on the coinciding lines. One is solving a system of equations using substitution. How can you determine if the system has one solution, no solution, or infinite many solutions? Well, let's think about it. One solution means you actually get a coordinate for x and y. No solutions means it creates a false statement, and infinite many creates a true statement. So if you are able to solve for x and y, it has one solution. If all variables cancel and you get a true statement, then that's when you have infinite many solutions. And a false statement means no solution. All right, I want you guys to hit pause and I want you to solve 5, 6, 7, and 8. I'm going to go ahead and just give you guys the answers. And if you guys get stuck, you guys can go ahead and just ask for questions on it. So for number 5, the answer is going to be a 2, 4. So if you don't get that, you did something wrong. We just need to figure it out. Number 6 is going to be 1, 2. Number 7 is going to be negative 4, 5. Number 8 is going to be infinite many solutions. And then on the last one, it's going to be 27 limited edition soccer balls and 43 pro NSL soccer balls. And that concludes our notes.